Welcome back to another video with Aman. So today is actually the lesson is about the last station of the first chapter, and today again we are gonna study something that you study a part of it in grade 9, but some of it might be new. So I would be happy to guide you, to help you, and to teach you, inshallah, during this video. So the title is, by the way, it's lesson 5 from the grade 10's book. And the title is Solving a System of Two Variables Linear Equations. So we are going to deal basically with systems of linear equations. Okay? So we have got some ways to solve this system. What I mean by solve, we need to find the value of x and y. All right, or sometimes they may be like different variables. Maybe they will be a and b, all right, or c and d, doesn't matter. But since x and y are common, so basically we talk about like x and y. So this is going to be the last lesson from chapter 1. That is the general form of a system of linear equations. Ax plus by equals to z. And cx plus dy equals to w. So instead of a, b, z, c, d, w, we will have numbers, of course. What else do we have here? So system of linear equations. When we have a system of linear equations, what way we need to use? We need to know to deal with that system to get the solution of it. All right, so we have got basically 3 ways. All right, the first way is substitution method, which is a common method that you studied last year at grade 9. And we have got elimination method, which is a method that it is very, very useful and we use it a lot. All right, and the last method actually is graphing method, that again we are going to deal with it at the end of our lesson. Okay. So you might ask me which one is more important. It depends on the question. It depends on the system. But I can order them in that way personally, like elimination, substitution, and graphing. All right. So page 42, we have got something regarding the substitution method. Like I can say the explanation of substitution method is at page 42. If it comes to page 42, it's going to give us this helpful explanation regarding the substitution method. Well, in substitution method, always we must find one of the variable in terms of the other one. So what is the goal? We need to find one of the variable in terms of the other one. Okay? In that case, in terms of the other one, in one of the equations, then substitute it into the other one. So let me just make it clear. You will have a system of linear equation. First, you have to find one of the variable in terms of the other one in one of the equation. Then when you find that, substitute it or replace it to the other equation, then you will deal only with one variable. Right now, we have got example. So, take a look at this example. The system is 2x plus y equals to 5. Okay? And y equals to 3x. That is a system that I talked about it. Look, linear equation, linear equation. So both of them are linear equations. The question is how to solve it, what method we should use. So as you can see, already it's given. In one of the equation, one of the variable is written in terms of the other one. What I mean by that, as you can see, y equals to 3x. So y is written in terms of x. In that case, we will substitute it in the other equation. So instead of that's y, I'm going to write 3x. Okay? Instead of that's y, I will write 3xy because y equals to 3x. So let's just continue. Okay, the first equation, bring the first equation 2x plus, instead of y, I will write 3x because as you can see, it's written y equal to 3x and then equal to 5. So as you can see, 2x plus 3x, 5x equals to 5. So here, what are we going to do? It's so easy. We already know about how to solve an equation. So divided by 5, divided by 5. That's 5 cancel this 5 and x equal to 1. That is the variable of that is the value of one of the variable. So we need to again go back to the equation that we have, like the second one, y equals to 3 times that x that we found it. So our x is 1. 3 times 1 is 3. So you are going to say that at the end, the solution is, you should write it as an order pair, okay? And it's better because that order pair shows us that the intersection point of these two lines, of these two equations, is 1 and 3. That 1 and 3, in another word, will tell us that these two equations will intersect each other, their graphs, at this point, which is 1 and 3. Perfect. So let's move to, as you can see, x equal to 1, and if you replace it into that one, I think, yes, 3 times 1, it's equal to 3. So at 1 and 3, these two lines will intersect each other. I guess I wrote 2 in the previous, in the solution that I made it, but 1 and 3. Perfect. So we have got questions, of course. This is the title of the question that you will deal with it during the exam. So solve this system. A system will be given by using substitution method. So let's come back to the substitution method and see what does it says. Page 42, try this example. We have got that system. X plus 4y. Just wait a second, please. Yes, substitution method. So as you can see, the value of one of them already is given. So the value of one of them is already given. Y equal to -1. So y equal to -1. It's given. So bring the first equation. The first equation is x plus 4y equals to -2. Now we have got the value of y. So substituted x plus 4 times, instead of y, I have got -1 equals to -2. So x, 4 times -1, -4 equals to -2. Move this -4 to the other side, so we are going to have -2 plus 4. Why plus 4? Here is negative. When it goes to the other side, it will become +4. Therefore, x equals to +2. All right? And then when we have x and y, so we can easily write the solution as 2 and -1. So it means that these two equations, they will intersect each other at this point, which is 2 and -1, right? Okay. The next question, let's see whether we have it. Yes, try this example. I mean, page 47, exercise 2. Page 47 of your book, exercise 2. I just wrote this example, that beautiful example. Again, for x plus y equals to 17 and y equals to -3. So again, one of the value is given. The value of one of the variable is given. Perfect. We are going to substitute it into the other equation and get the value of the other variable. Perfect. So we have got 4x plus y equals to 17. We have the value of y. So for x, instead of y, I'm going to write -3 equals to 17. I hope that it is clear till now. So move this -3 to the other side. It's going to become +3. So we have got 4x equal to 17 plus 3, 20. Divide both sides by 4. X would be 20 over 4, 5. So we found x and we already have y. So the solution would be 5 and -3. That is the point that these two the graph of these two linear equations will intersect each other at. Perfect. the next thing that you need to know, okay, two variable linear system solution. Okay, when we have a system of linear equations, the question is, are we going to have always one solution? So here is the point that we are going to find it out. So the first case is we might have no solution. We might have no solution. When here is the two equations, here the two equations are parallel. When the two equations that we have got in our system are parallel to each other, in that case there won't be any solution for our system because they will never intersect each other. Parallel line, they will never ever reach each other. That's why we don't have any solution for a system that its equations are parallel. Okay. The next one is infinitely many solution. As you can see, these two graphs are coincident on each other at every single point. So infinitely many solutions said that here, in that case, both equations are coincident and have infinite solutions. So when our system have two equations and they are exactly over each other at every single point, which means they are coincident, in that case we are going to have infinite solution. Okay, one solution, most of the examples I can say, like most of the questions, exercises, examples are regarding to this case, especially in our book. So one solution, when we are going to have one solution, just based on those examples that previously we solved for substitution, in all of them we got only one solution. So here are the explanation for one solution. The two equations intersect at a single point, and the point of intersection becomes the point of solution of the system. As I already mentioned, that point that we have got was the point of the intersection between those two equations that we have. That is the story of the number of solutions that we can have for a system of linear equations. Okay, let's come to the next method, which is elimination method. So in elimination method, the story is in this way. According to its name, we should eliminate. We should remove one of the variable. How? First, we need to add both equations. So the first step is always we must eliminate one of the variable by adding the two equations to each other. If elimination process was happened, that's okay. Go on and find the value of the variables. If not, we need to we need to make the elimination happen. How? By multiplying or dividing, mostly multiplying the equation, one of the equations by a number to make the elimination happen. Right now we will see it. Okay, after getting the value of one of the variable, we should substitute it into the other equation to get to one of the equation, actually, not to the other one, to get the other variable. So still not. Okay, let's see whether we have got an example or not. Yes, as you can see, x minus 2y and 4 equal to 7, 4x plus 2y equals to 8. You might ask me, okay, what is the difference between substitution and elimination? Can we use elimination for substitution for those systems that we can solve like substitution method? Yes, the answer is definitely yes. You can solve it. You can solve it. Sorry for the interruption. So you can solve it, yes. But for example, it depends on the title of the question. If the question asks you to solve the system by using elimination, so you have to go with elimination. And if the question asks you to use substitution, well, you need to use a substitution method. But again, I'm going to repeat it. Elimination, we can use those systems that the question asks you to solve it by substitution. We can use elimination for them as well, and vice versa. But let's come back to this question regarding to elimination. Well, we have got a system x minus 2y equal to 7, and we have 4x plus 2y equals to 8. Well, what is the first step لطفاً don't forget about this step. The first step is in elimination is adding these two equations that we have. When we add them, we will find out whether any of the variable eliminated or not. If it was eliminated, okay, go ahead. If not, we need to make the elimination happen. Perfect. So here, if we add them, you can see that x plus 4x, 5x, negative 2y and positive 2y, when you add them, so they are going to cancel each other, and what will remain? Let me just use my pen. Yes, I guess red is better. So these two opposite and equal coefficients, so they are going to cancel each other. Nothing in terms of y will remain. So 5 and 7 plus 8, 15. So 5x equals to 15. That is a single step equation. Divide both sides by 5. You are going to get x equals to 3. That is the variable, the answer for x. How about y? How are we going to get y? So in that case, when you found one of them, try to bring it to one of the equations. Use one of these in order to get the value of the other variable. For instance, here I use the first equation, x minus 2y equals to 7. Well, you can use the second one as well, because at the end you are going to get the same answer. Perfect. So I just brought this equation, x minus 2y equal to 7. So instead of x, I will put 3. Replace x to 3. Why? Because we got 3 as x. So 3 minus 2y equal to 7. Now move the number to one side. Move this 3 to the other side. Here it's positive 3, so it's going to become negative 3. So we are going to have negative 2y equals to, if 3 comes to here, so 7 minus 3 would be equal to 4. Now we have got negative 2y equals to 4. Divide both sides by negative 2. You are going to get y equals to 4 divided by negative 2, negative 2. So then you are going to say that, okay, the solution is x and y. X was 3, y is going to be negative 2. Perfect. This is how we are dealing with elimination. Don't forget this step that most of you, unfortunately my students, they forget it. Like, first of all, you should add those two equations to see whether elimination happened or not. If happened, go ahead. If not, multiply or divide one of the equations by something to make the elimination happen. Let's just follow these examples that we have got here, page 43 of your book, and try this example. Solve this system. We have got a system here by using elimination method. All right. So solve the system. What was the first step? Adding the equation. So let's add them. 2x plus x, 3x. Negative y plus 2y, only 1y will remain. 4 plus 2, it's going to be equal to 6. Does any one of them eliminate each other? No. Still we have got x and we have got y yet. That's why we need to make some change by ourselves. What I mean by we need to make some change, follow me to see it. Okay. So first of all, decide what variable you want to eliminate, x or y, doesn't matter. So you have to decide in order to go ahead, okay? Because here is the point that most of the students will ask me, teacher, where did you bring this number? So listen to me carefully. Let's just go with like eliminating y, okay? So you can go with like eliminating x, but I would love to go with y here. So I have got 2x minus y equals to 4. X plus 2y equals to 2. So my change that I said, here the coefficient of y it's negative 1 and here is positive 2. We said that elimination will happen when the coefficient of that variable would be equal and opposite. So here is 2. How can we make 2 here? By multiplying by 2. And since the signs are opposite, that's better for us. One is positive, the other one is negative. So multiply the whole equation by 2 and see what will happen. So 2 times 2x, 4x. 2 times negative y, it's equal to negative 2y. 2 times 4, 8. And rewrite the second equation, x plus 2y equals to 2. Perfect. So right now, let's add them again. 4x plus x, 5x, negative 2y, positive 2y, they will eliminate each other, they will cancel each other, nothing will remain, equals to 8 plus 2, 10. Right now, divided by 5, divided by 5. So x would be 10 divided by 5, 2. You got x. Substitute it into one of these two equations that you have. So I would love to choose this one. Perfect. So what do I have here? I have x plus 2y equals to 2. Instead of x, I have got 2 plus 2y equals to 2. Move the number to the number side. So here is positive 2. If it comes to here, it's going to become negative 2. Perfect. So we have got 2y equals to 2 minus 2, 0. Divided by 2, divided by 2. Y equals to 0 over 2. Do not say 2. 0 over number, it's 0. Perfect. So you got the solution. The solution is x and y. X is 2 and y is 0. I hope that you understood it. Perfect. Let's go to the next question. Here, okay. This is an interesting question, by the way, because except elimination, you can use substitution. So I'm going to go with both ways. So here I would write sub, which means substitution, and here I would write elimination, which means elimination method. Okay, for elimination we said that, actually I did not, but here let me just say it. The variables must go to one side and the constant term, which is the number, must stand in one side of the equal sign. Perfect. As you can see here, the number is not alone, so we need to move this x to the other side in order to line up the terms. So in that case, it's positive x. When it comes to the other side, it's going to become negative x plus y equals to negative 3. Remember, I just moved x to the other side. And then rewrite the second one, x plus y equals to 5. That is our system. Let's add. What was the first step? Adding the two equations that we have, negative x and x, they will kill each other. You see, elimination happened already. Y plus y, 2y equals to 5 minus 3, 2. Divided by 2, divided by 2. So y equals to 1. Now substitute it into one of these equations. Perfect. So I would like to use the second one. X plus y is 1 equal to 5. Move this 1 to here. So it's going to become negative 1. X equal to 5 minus 1, 4. You got x and y, so the solution is 4 and 1. How about substitution? Well, substitution, this one is easier to use substitution because one of the variable is given in terms of the other one. So bring the second equation, x plus y equal to 5. That's y is given and it's equal to x minus 3. Look at the first equation. X plus, instead of y, I would write x minus 3. X minus 3 equal to 5. Now, we have got only one variable, x plus x, 2x. Move this negative 3 to the other side, it's going to become positive 3. 5 plus 3, 4. Divided by 2, 5 plus 3, 8. Divided by 2, divided by 2. So x would be 4. Here is x. And for getting y, again go back to the system. So y is x minus 3. We got x. So y equals to, let's just replace it. 4 minus 3. So y equals to 1. y1, x4. y1, x4. Doesn't matter which method you are going to use. You will get the same answer. Perfect. You may just take a photo. Perfect. It was page 47, example 10. Exercise 10, sorry. Let's see whether we have another question or not. Page 45, example 4. Solve this system by using elimination. Elimination is important, honestly, guys. That's why we solved that much example regarding to it. So 2x plus 3y equals to 4, 4x plus 6y equals to 8. The first step, adding. So add them. 2x plus 4x, 6x. 3y plus 6y, 9y. 4 plus 8, 12. None of them eliminate each other. So we need to make some changes. So bring it here. This is our system. 2x plus 3y equals to 4. 4x plus 6y equals to 8. So either you want to eliminate x or y, you need to decide. So I would love to go with x's. Okay, I want to eliminate x's. Perfect. Here we have got 4 and here we have got 2. Basically, the signs are not opposite, so we should multiply by a negative number. The first one, of course, negative what? 2 times what is going to give us the opposite of 4? What is the opposite of 4? Negative 4. How can we make negative 4? By multiplying by negative 2. So here is 8, be careful. So the change would be in this way. Negative 2 times 2x, negative 4x. Negative 2 times 3y, negative 6y. And negative 2 times 8, negative 8. So here we will rewrite this one. 4x plus 6y equals to 8. Now add them. 6. Negative 4x will cancel 4x. Negative 6y will cancel 6y. So 0 will remain from this side. 8 minus 8, 0. Aha. When you got the same answer from both sides, we are going to say that our system has infinity many solutions. Infinity many solutions. Doesn't matter, like it's not fixed. You might get 2 equals to 2. When both sides are the same, when both sides are equal, so you are going to get you are going to say that our system has infinity many solutions. Okay? Why do we say that? Because these two lines are parallel to each other. When two lines are parallel to each other, when two lines are coincident, which means they are over each other, they touch each other, they actually intersect each other at every single point. In that case, you are going to say that we have got infinity many solutions. Remember, in the previous slides, we discussed about the number of the solution, and one of them was infinity many solutions when the two lines are coincident on each other. So in that case, we're going to say that we have infinity many solutions. Or algebraically, if we got the same number from both sides, for example, 2 to 0 equals to 0, 10 equals to 10, 100 equals to 100, in that case, you're going to claim that our system has infinity many solutions. Perfect. I hope that was clear. The next question, do we have it? Yes, page 45. Try this. Okay. What was the first step in elimination? Adding the equation. So x plus 3x, 4x, negative 3y minus 9y, negative 12y, 1 plus 3, 4. They did not eliminate each other, so make some change. Perfect. Bring this system here. X minus 3y equals to 1. 3x minus 9y equals to 3. So which one do you want to eliminate, x or y? It depends on you. So the previous one I went with x. So this time I'm going to go with y, and I will try eliminations of y. So here we have got negative 3 and here we have got negative 9. So we need to make positive 9 here. How can we get positive 9 from negative 3? So negative 3 times what will give us positive 9? Times negative 3. Why? Because negative times negative positive. 3 times 3, 9. Therefore, we need to multiply that equation by negative 3. And let's see what we are going to get. We are going to get negative 3 times x, negative 3x. Negative 3 times negative 3, positive 9y equals to negative 3 times 1, negative 3. Perfect. And rewrite the second one. 8. Is that 8? No. 3x minus 9y equals to 3. The same situation, the same story of the previous one. Negative 3x kill this one. 9y will kill this one. 0 will remain. 3 minus 3, 0. Since we got 0 from both sides, we are going to say that our system has infinity many solution. That's it. How about the next question? Let's see whether we have got it or not. Yes, page 45, example 5. Solve this system by using elimination. What is the first step in elimination? Adding the two equations that we have. 2x plus 4x, 6x. Y plus 2y, 3y. 3 plus 2, 5. Sorry, 5. Perfect. And here, so as you can see, none of them eliminated each other. Either x, neither x nor y. So in that case, let's do our chains. Okay. So bring our system here. 2x plus y equals to 3. 4x plus 2y equals to 2. Decide whether you want to eliminate x's or y's. So previously I went with y, so this time I will try x. So here we have got 2 and here we have got 4. How can we make opposite? What is the opposite of 4? Negative 4. So we need to make negative 4 here by multiplying these two by negative 2. Why? Because 2 times negative 2, negative 4, which is the opposite of 4. Perfect. So in that case, we are going to have negative 4x, negative 2 times y, negative 2y, negative 2 times 3, negative 6. And we have got 4x here plus 2y and equals to 2. So negative 4x to 4x, they cancel each other. Negative 2y, positive 2y, they cancel each other. So here we are going to get 0. Negative 6 and 2, we will get negative 4. The question is, are these two sides equal? Absolutely not. So since they are not equal, you will say that our system has no solution. Why? Because these two lines are parallel. Parallel line, they will never ever intersect each other. Since they don't intersect each other, there is no intersection point. Well, there is no solution for such a system. All right. So you are going to say that there is no solution for our system. There is no solution. That is regarding to no solution case as well. Okay, let's come to the last method that we need to know, graphing methods. Well, remember that in grade 9 you study about something that's like, I guess it is in chapter 3, the beginning of chapter 3. You study about the linear functions. First of all, you study like what kind of functions are linear. Then you discuss about slope intercept form, and then you discussed how to graph it. For that reason, you study intercepts. Okay, sorry. So intercepts, we need to work on intercepts. Let me just check whether the video is okay or not. Yes. So we need to know like the intercepts of a linear function in order to graph it, because like finding the intercepts is the easiest way to graph a linear function. Perfect. So let's see what we have about graphing. In graphing method, we will use the intercepts to graph the equations. For what reason? To figure out how many solutions does the system have. So in that case, it's going to tell us that graphing method will not tell us what is the solution. It's not going to ask us like substitution and elimination, what is the solution? Find out the solution. It's like it focused more on the number of solutions. So how many solutions do we have? Otherwise you can find the solution as well, okay, if you just graph them like accurately. But the importance of graphing method is about finding out the number of solutions. Either our system has one solution, no solution, or infinity solution. Perfect. Let's just deal with some example. Page 46, example 6. Perfect. Solve this system by using graphing method. Well, graphing method, we said that for each equation, for example, look, the first equation, 2x minus 3y equals to 6. We need to find x-intercept and y-intercept. Well, in x-intercept, y-coordinate is 0. Remember this and don't forget it. In x-intercept, y is 0. In y-intercept, x is 0. Don't forget this relation between the intercepts. Okay, so in x-intercept, y is 0, so make the terms of y 0. What will remain? 2x equals to 6 divided by 2 divided by 2. 6 divided by 2 should be. That is regarding to x-intercept. How about the y-intercept? So for y-intercept, make x 0. So this time make this one 0. What will remain? Negative 3y equal to 6 divided by negative 3 divided by negative 3. 6 divided by negative 3, it's negative 2. These are the intercept for the first equation. You have to find the same thing for the second equation. Okay, let's just do it. The second equation is x minus 2y equals to 4. So find x-intercept and y-intercept. In x-intercept, y is 0. In y-intercept, x is 0. Perfect. So let's make y 0. If you make y 0, so in that case, x would be 4. 4 here. And if for y-intercept, if you make x 0, so what will remain? Negative 2y equals to 4. Divided by negative 2 divided by negative 2. Y equal to 4 divided by negative 2, negative 2. Now, draw a coordinate plane. And let's plot these points and find out the graphs. Well, for the first graph, we have 3 and 0. So 1, 2, 3. Here is the point. 0 and negative 2 for the y-intercept. 0 and negative 2. Negative 1, negative 2. So here is negative 2 and here is 3. So here is the second point. Now, I want you to match them to see the graph. So here is the first graph. Here is the first graph. How about the second graph? So we have got 4 and 0. So let's say 4 is here. That is the first point. And we have 0 and negative 2 again. So 0 and negative 2 exactly here. So right now, okay, these two graphs. As you can see, these two graphs intercept each other at only one point. Where is the point? The point is over here. So it means that our system has only one solution. And the solution, by the way, here it's clear. The solution is 0 and negative 2. While they will just ask you that how many solutions does the system have? All right. In that case, since these two lines intersect each other at only one point, you will say that only one solution. Perfect. So the next question, page 47, exercise 11. The same thing. Graphing again. Well, for graphing, we said that bring each equation. Green is not much clear. So 2x minus 3y equals to 1. And we need to find x-intercept and y-intercept. How are we going to do it? We know that in x-intercept, y is 0. In y-intercept, x is 0. Perfect. So in x-intercept, since y is 0, make y 0. So this term is going to be 0. What will remain? 2x equals to 1. So x would be 1 over 2. Y divided by 2 divided by 2, x would be 1 over 2. So write 1 over 2 here. How about the y-intercept? For y-intercept, make x 0. What will remain? Negative 3y equals to 1. So divided by negative 3 divided by negative 3. In that case, y would be negative 1 over 3. Okay, that is for the first equation. Let's go for the second equation. Second equation is what? 3x plus 4y equals to 10. So x-intercept and y-intercept. In x-intercept, what is 0? Y 0. In y-intercept, x is 0. So for the x-intercept, let's make y 0. If we make y 0, 3x equals to 10. Divided by 3, divided by 3. So x would be 10 over 3. That is the x-intercept. Doesn't matter, it's a fraction. So it's okay, completely normal. How about the y-intercept? Make x 0. So make x 0. What will remain? 4y equals to 10. divided by 4, divided by 4. That's going to go with this one. Y equals to 10 over 4. Okay, so we got the x-intercept and y-intercept for each equation. The only thing that you need to do is plot them and match them and graph them. Perfect. So let's just do it. Okay, for the first graph, we have got 1 over 2 and 0. Let's imagine 1 over 2 is here. Okay, 1 over 2 and 0. And 0 and negative 3. So let's say negative 3 is here. So if you just match them, that is going to be the graph of the first function. How about the second one, the second graph? Well, the second graph, we have got 10 over 3. So 10 over 3, it's almost 3 point something. So let's say if here is 3, so 10 over 3 would be here. Okay? So 10 over 3 would be that point. And how about 0 and 10 over 4? So 10 over 4, it's on the y-axis. So it's positive, so go up. Perfect. 10 over 4, it's 2 point, let's say half. Okay? So if here is 2, 10 over 4 would be somewhere here, around here. So let's just imagine this is 10 over 4. And here is 10 over 3. Perfect. So join them. Let's just join them. Here is going to be the graph. In how many points they intersect each other? At only one point. Here is the point. Since at only one point they intercept each other, in that case, you will say that our system has only one solution. That's it. And I hope that you understood it. Here is the solution. Perfect. Let's go to see whether we have got any other question or not. Yes, we have got one more question. Let's just solve this one, and I guess that is going to be the end of chapter 1. Solve the system by using graphing method. So we have got 3x minus y, 3x minus y equals to 6. So find the x-intercept and y-intercept. So for x-intercept, we know that y is 0. And for y-intercept, we know that x is 0. Okay, so for to find x-intercept, let's make y 0. If you make y 0, so 3x equals to 6 will remain, divided by 3, divided by 3. 6 divided by 3, 2. Okay, how about y-intercept? Make x 0. So in that case, we are going to have negative y equal to 6. Multiply by negative 1, so in that case, y would be negative 6. So negative 6. Why we multiply by negative? Because we need to find positive 1y. So here we have got negative y. In order to remove that negative, we need to multiply by a negative number. Perfect. That is the intercept for the first equation. How about the second equation? So we have got x plus 2y equals to 9. We just write it a little bit upper in order to have enough space. So x plus 2y equals to 9. We need to find the x-intercept and y-intercept. X-intercept. In x-intercept, y is 0. In y-intercept, x is 0. Perfect. The function, okay, for x-intercept, make y 0, so x would be 9, easily. And for y-intercept, x would be 0, so 2y equals to 9. Divided by 2, divided by 2. Y is 9 over 2, which is almost 4.5. So 9 over 2. Okay, so we have these 4 points. Let's just plot them on this coordinate plane. Okay, for the first graph, 2 and 0. Let's say 2 is here, so 2, 0 is that point. 0 and negative 6. Negative 6 is here. Let's just imagine it. Okay, negative 6 is over there. So if you just join them, we are going to have that graph. Perfect. How about the next one? The next one is x-intercept is 9 and 0. 9 and 0. Imagine 9 is here. So this is going to be 9 and 0. 0 and 9 over 2. Since it's positive, so we need to go to the we need to go upward. Okay, 9 over 2 is almost 4.5, and 9 divided by 2 is 4.5. Imagine if here is 4, so here it's going to be 4.5, which is 9 over 2. Perfect. So I want you to join these 2 points to see the graph of the second equation. Was not that much accurate, so let's just imagine we are, and in how many points these two graphs intercept each other? So at only one point. They intersect each other at this point. In no other point they won't. That's why we are going to say that our system has only one solution. That's it. If they intercept each other at only one point, one solution. If they didn't, no solution. And if they exactly were coincident, which is they were over each other, so in that case we are going to say that infinite solutions. Perfect. And that is the solution of this question. And I hope that you guys understood the lesson, the methods, and the questions. Please take notes and try to watch the video completely in order to not lose any part of it. I will see you in another video. Take care and study well. Thank you so much for listening to me.